3 hours ago, NASA released a statement that has scientists around the world going silent. An object the size of a small city traveling from another star system just did something that's never been documented in the history of astronomy. It slowed down on purpose, and the way it did it, it matches almost perfectly with how you design a spacecraft brake. The object is called 3I/Atlas, and what it just did? We're going to unpack every single detail by the end of this video, because if what NASA is suggesting is true, we're not looking at a comet anymore. We're looking at something that was sent. But before we get there, quick question. Where in the world are you watching this from right now? Drop your country or city in the comments. I'm genuinely curious how far this story is spreading. All right, let's rewind, because to understand what just happened 3 hours ago, we need to go back to where this whole thing started. And trust me, every single piece of this puzzle matters. July 2025, a telescope in Chile picks up a faint dot moving across the night sky. Happens all the time. Asteroids, comets, space rocks, we catalog them and move on. But within 48 hours, astronomers realized something was very, very wrong with this one. The trajectory wasn't elliptical, it was hyperbolic. That's the math term for this thing is not from here. It's an interstellar object, only the third one we've ever confirmed, and it was already behaving strangely. They named it 3I/Atlas. The I stands for interstellar, and by early August, when most comets at that distance should be dormant, cold, inactive, this thing was already spewing material. Not just a little, 40 kilograms per second, like a fire hose, at a distance where water ice shouldn't even be sublimating yet. Scientists were confused, but okay, maybe it's rich in carbon dioxide. CO2 can outgas at greater distances. So they kept watching, and then they saw the tail. Except it wasn't a normal tail. The tail was pointing forward in the direction the object was traveling, not streaming behind it like every comet we've ever studied. Forward, like exhaust from a rocket engine. They called it an anti-tail, and that's when Avi Loeb, the Harvard astrophysicist who's been studying interstellar objects for years, published a paper that made a lot of people uncomfortable. He said, and I'm paraphrasing here, if you wanted to slow down a spacecraft entering a solar system, this is exactly what it would look like. Because think about it, you're traveling at 210,000 kilometers per hour through interstellar space. You enter a new star system, you need to slow down. What do? You fire your engines in the direction you're traveling. You create thrust opposing your motion, and that thrust, it would produce a plume of exhaust shooting out in front of you, an anti-tail. Now, that alone wasn't enough to make anyone jump to conclusions. Comets can be weird. They do unexpected things. But then, in September, something changed.
The Nordic Optical Telescope in the Canary Islands captured new images. The anti-tail was gone. In its place, a traditional tail, streaming behind the object, like every normal comet in the solar system. The transition happens somewhere around 2 astronomical units from the Sun. That's twice the distance between Earth and the Sun. And the timing is what has people asking questions, because if this were a braking maneuver, if you were piloting a craft from another star, you'd want to complete your deceleration burn before you got too close to the Sun. Too much heat, too much radiation, it could damage your systems. 2 AU, that's a perfect distance to finish slowing down. And then, once you've shed enough velocity, you shut off the engines. At that point, natural solar radiation takes over. Material starts getting stripped from the rear of the object, a normal tail forms. That's the sequence we just observed. Anti-tail to tail, forward thrust to passive outgassing. And here's where it gets even stranger. When they analyzed the composition of that anti-tail, they found something that shouldn't exist in nature. A nickel alloy. Not just nickel, an alloy. A specific blend of metals that, on Earth, we manufacture intentionally for high-strength aerospace applications. Now, scientists are being careful. They're saying maybe, under extreme unknown conditions in a distant star system billions of years ago, natural processes could have created this alloy. Maybe there are formation mechanisms we don't understand. But here's the problem. With every observation, the maybes keep piling up. Maybe the nickel alloy formed naturally. Maybe the antitail is just a weird rotational quirk. Maybe the transition at exactly 2 AU is a coincidence. Maybe the extreme CO2 to water ratio is just unusual chemistry. Maybe the water production at impossible distances is a new type of comet behavior. At what point do we stop saying maybe and start asking, what if? This object is between 2 and 6 kilometers across. That's the size of Manhattan. It's 7 to 10 billion years old, formed before our sun even existed. It's been wandering the galaxy, surviving radiation, cosmic rays, collisions with interstellar dust, and somehow it's still intact, still active, still functional. Most ancient comets are fragile. They break apart, they disintegrate, but not this one. And then there are the brightness variations. Back in August, researchers noticed the object's brightness was changing in ways that didn't match a simple rotation pattern, like something was reorienting, like something was adjusting its position. The International Asteroid Warning Network, the group that tracks near-Earth objects for NASA, added 3I-AT Atlantis to their official target list. Not because it's dangerous, it's not going to hit us, but because, and this is a direct quote from their website, it represents an unprecedented scientific opportunity. They're coordinating observations across multiple continents, mobilizing telescopes, treating this like a high-priority target. And the question everyone's avoiding in public, but asking in private, is why?
October 29th. That was the date. Perihelion, the closest point to the sun. 3I Atlas was about to pass within 130 million miles of our star and then disappear behind it for 2 weeks. 2 weeks where we couldn't observe it. 2 weeks where anything could happen. And scientists knew this was the moment. If this object were going to do something, if it were going to make another maneuver, perihelion would be the perfect time. Maximum solar radiation, maximum cover. And when it emerged on the other side, we'd have no idea what happened during those 2 weeks. Ground-based telescopes tracked it right up until it vanished behind the sun. NASA's SOHO spacecraft, designed to study the sun, caught glimpses as it passed through the field of view. Low resolution, but enough to see that it was still active, still outgassing. The tail was growing. And then it disappeared. For 2 weeks, the scientific community waited. No observations, no data, just models and predictions about what the object should look like when it reappeared in early November. They calculated the expected trajectory based on gravitational forces, solar radiation pressure, outgassing effects, everything that could influence the path of a natural comet. And they waited to see if 3I Atlas would match those predictions. Early November, it reappeared. Pre-dawn sky. Telescopes locked on immediately. And that's when they saw it. The trajectory had changed, not by much, but enough. Enough that it didn't match the predictions. The object was moving slightly faster than it should have been, and the direction, the angle, it was off by a fraction of a degree. For a natural comet, those kinds of deviations can happen. Outgassing can create small thrust forces. Jets can push the object in unexpected directions. So scientists ran the numbers again. They modeled every possible natural explanation. Asymmetric outgassing, rotational effects, hidden jets, everything. And none of it fully explained what they were seeing. Then, 3 days ago, NASA's HiRISE camera on the Mars Reconnaissance Orbiter, those images that had been locked away due to the government shutdown, they finally got released. And when researchers saw them, everything changed. The images showed surface features, structure, but more importantly, they showed the active regions, the places where material was being ejected. And the pattern, the distribution, it wasn't random, it wasn't chaotic like you'd expect from a natural comet with irregular ice deposits. The jets were positioned, arranged in a way that if you were designing a spacecraft, if you wanted precise control over your trajectory, that's how you'd place your thrusters. NASA didn't say anything publicly at first. They circulated the images internally, ran simulations, brought in propulsion engineers to analyze the jet patterns. And yesterday, they released a preliminary report to the International Asteroid Warning Network. That report is what leaked 3 hours ago, and it's what has the scientific community in an uproar right now.
Here's what NASA's report says, in careful scientific language.
The observed trajectory deviation of 3I/Atlas following perihelion passage is inconsistent with models of passive cometary outgassing. The magnitude and direction of the velocity change, combined with the spatial distribution of active regions observed in high-resolution imaging, suggests the possibility of controlled propulsive maneuvers. Let me translate that. NASA is saying this thing might have brakes, and it just used them. Not definitely, not conclusively, but they can't rule it out. And for NASA to even suggest the possibility of an artificial object in official documentation, that's unprecedented. That's a line they don't cross unless the data is forcing their hand. If this is true, if 3I/Atlas is artificial, here's what it means. First, we're not alone. There is, or was, another technological civilization in our galaxy, one advanced enough to send objects between stars. Second, interstellar travel is possible, not just theoretically, actually possible. Someone did it. Third, our solar system is being visited, not by radio signals, by physical objects, probes, spacecraft, things that can observe, maneuver, potentially report back. And fourth, we've probably missed dozens, maybe hundreds of these things. Because if we've detected 3 interstellar visitors in just 8 years, and they're this diverse, this strange, then our galaxy is full of wandering objects. Most of them too faint, too fast, or too well camouflaged for us to notice. Think about what this object has seen. 7 billion years old. It was built or formed when the universe was half its current age, when our sun didn't exist, when Earth was still just a cloud of dust and gas that hadn't even begun to coalesce. It watched galaxies collide, supernovas explode, stars being born and die, and somehow it survived. It kept going. And now it's here, in our solar system, passing through our neighborhood, and we're watching it. We're seeing it. We're asking the same questions it might have been designed to answer. Is there life out there? Is there intelligence? Are we alone? And maybe, just maybe, the answer is written in the trajectory of a 7 billion-year-old object that just fired its engines in front of us. Right now, 3I/Atlas is heading back out into interstellar space. It's leaving, and we'll never see it again. But every major observatory on Earth is tracking it. NASA has redirected space telescopes. International teams are coordinating observations around the clock. Because if there's even a 1% chance this is artificial, then every data point matters. Every image, every spectrum, every measurement. This is the most important object humanity has ever studied, and most people don't even know it's happening. So share this video, talk about it, ask questions, because whether 3I/Atlas is a comet or a spacecraft, we're living through something extraordinary. We're witnessing either the most unusual comet in recorded history, or we're witnessing first contact. And in a few months, once all the data is analyzed, once every possible natural explanation has been tested and either confirmed or ruled out, we'll know. But right now, in this moment, we're in the space between not knowing and finding out. And that space, that's where history gets made. Before you go, if you found this fascinating, I just posted a deep dive on what happened to Oumuamua, the first interstellar visitor, and why scientists now think we completely misunderstood it. Link in the description. And seriously, drop a comment about where you're watching from. I want to see how global this story is getting. Thanks for watching, and keep looking up, because the universe just got a lot more interesting.